Today I am going to focus on acceleration due to gravity, which is denoted by g, and factors affecting the g. And this g is a small g, not capital G. Capital G is for gravitational constant, but this is small g is acceleration due to gravity. What is it? Acceleration due to gravity can be defined like this. Acceleration developed on a freely falling body due to the gravity of the earth is called acceleration due to gravity. Look at this word, freely falling body. It means there is no any resistance, and acceleration due to gravity is possible only in vacuum. In air, the motion of the body will be obstructed by the air. Okay, its average value is 9.8 meter per second square. We can understand this very clearly like this. If a body is dropped from certain height, it will certainly fall in a straight line. And first, its velocity will be 0 when it is not dropped. And when it is dropped exactly after 1 second, its velocity becomes 9.8 meter per second. And at the end of second its velocity increases to 19.6 meter per second, and at the end of third second its velocity increases to 29.4 meter per second. Every second velocity is increasing and increasing and increasing, and this increment is of 9.8 meter per second. Look at this. In first second increment is 9.8, in second also 19.6 minus 9.8 becomes 9.8 meter per second. Here also 29.4 minus 19.6 gives 9.8 meter per second. Every second velocity goes on increasing, and this increment is by 9.8 meter per second. Because of less velocity in first second, it covers less distance, but in second it covers more distance because of more velocity, and in third second it covers more distance. Since velocity is increasing, that's why distance covered in every second will also be increasing, and its acceleration will be 9.8 meter per second square. This is acceleration due to gravity. I want to tell you another matter also. When a body is dropped from very great height, at this time also it falls down in a straight line, but it falls in such a way that every second its velocity goes on increasing this way, and it covers more and more distance. In first second, if it covers this distance, second more, third second more, because its velocity is increasing and increasing. The reason is very simple, because it is pulled by the gravity of the earth. Earth pulls it towards its center, and because of this gravity force of the earth, the body accelerates. Acceleration never produces without the force, and gravity force is responsible to produce acceleration on this body. But when its speed increases in the air, then air resistance also increases, and air resistance acts in opposite direction, which is against the motion of the body. So air resistance goes on increasing due to the increase of the velocity of the falling body, and a condition comes when air resistance neutralizes the gravity. When air resistance is neutralized by gravity, then the body begin to fall with uniform velocity, not acceleration, because force is seized by air resistance. That's why now it falls with uniform velocity. And so we can say that there is two types of motion. At the beginning, the body falls with acceleration due to gravity, but when air resistance neutralizes the gravity, then it falls with uniform velocity. Now let's talk about the factors which affects the value of g, small g. Number 1, the radius of the earth. Earth is flattened at pole and bulged at equator. That's why its radius is different in different places. Polar radius is less, equatorial radius is more, and its radius is different in different places, and accordingly value of g also varies from place to place. We'll talk in detail about the same later. G depends upon height from the surface of the earth. The height from the surface of the earth decreases the acceleration due to gravity. Value of g becomes less. Depth from the surface of the earth. As we go to the depth of the earth from the surface, let's say at this place, then the acceleration due to gravity at this place is less than the surface. This is very interesting. When we go to height, g decreases. When we go inside the earth, G decreases. This way, G is maximum on the surface of the earth. Okay, axis rotation of the earth. Earth is rotating like this in its own axis. Because of this rotation, the value of G is less. Later we'll discuss about this also. Okay, let's go to another part. G is inversely proportional to the square of the radius of the earth. It is symbolically represented here. We are going to prove this. Acceleration due to gravity depends upon radius of the earth, first point, and we are going to prove this how it depends upon radius and y square of the radius of the earth. We can prove this way. Let's say this is earth and its mass is capital M and its radius is denoted by capital R and the mass of the body lying on its surface is small m. We can say that let capital M be the mass of the earth, small m be the mass of the body lying on the surface of the earth, and r is the radius of the earth, and small g is acceleration due to gravity. Capital G, certainly gravitational constant. Now according to Newton's law of gravitation, F is equal to G capital M small m by r square. The distance between them is r, that's why d square becomes r square, and mass of first body is capital M, second body is small m, that's why capital M and small m is written in the formula. And this is equation number 1. Now we know this also according to Newton's second law of motion, F equal to mg. This is equation number 2. Here we have F and here also F, the same gravitational force acting on the body of mass m is taken here also, and that's why combining equation 1 and 2, what we get, mg is equal to G capital M small m by r square. We can cancel m and the result is G is equal to capital G capital M by r square. But here is a little problem. Capital G and capital M are constant. What it mean? When a body is dropped at pole and the same is if dropped at equator, at this time the capital G remains same. Capital G is constant. It doesn't make any difference to small g. In the same way, when a body is dropped at pole and in equator, then the value of the mass of the earth remains same. That's why capital G and capital M are not responsible for the variation of small g. Actually, it depends only on the radius of the earth. So we can say this way, here capital G and capital M are constant and G is so inversely proportional to square of the radius of the earth. I want to tell you about this equation. This equation is very important, which is used to solve the numerical problem also. So why don't we use this equation to solve one numerical problem? Look at this problem. Mass and radius of Jupiter is given 1.9 into 10 power 27 kg and 71 into 10 power 6 meter respectively. Find the acceleration due to gravity on it and what will be the weight of a man of 75 kg mass on it. First, we have to write the given. Mass of Jupiter capital M is equal to 1.9 into 10 power 27 kg and radius is also given. It is 71 into 10 power 6 meter. Now mass of man M is equal to 75 kg. Acceleration due to gravity small g is equal to what? And there is another question also. Weight of the man W equal to what? Here gravitational constant capital G is missing, that's why we have to write ourselves. Now I am using that equation which is mentioned just before this numerical problem. What is it? Small g is equal to capital G capital M by r square. Now we are taking value. Capital G is 6.67 into 10 power minus 11. Capital M is 1.9 into 10 power 27. And here in place of r we are writing the radius 71 into 10 to the power 6 and radius is square, that's why square is here. In second step, in numerator the same, but in denominator 71 into 10 to the power 6 whole square means we can write 71 into 10 to the power 6 twice, and that's why I am writing the same. And 6.67 and 1.9 when multiplied, then we'll have 12.673. Number interact with number and 10 power of 10 interact with power of 10, that's why 10 to the power minus 11 and here 10 to the power 27 same base, that's why the power can be added or subtracted, minus 11 plus 27. In denominator 71 into 71 gives 5041 and 10 to the power 6 plus 10 to the power 6 is 10 to the power 12. Now next step is we have to divide 12.673 by a big number 5041. When we divide we will get this value, and 10 to the power 27 minus 11 is 10 to the power 16, and 10 to the power 12 remains same. Now I'm going to take this 10 to the power 12 in numerator. Now we'll have 0.002513 into 10 to the power 16 minus 12, because this power when goes up it becomes 10 to the power minus 12, and 16 minus 12 becomes 4. And in next step I'm writing this. Now in this step what we are going to do, we have to multiply this with 10 to the power 4. 10 to the power 4 means 10,000. When 10,000 multiplies this very small number, then we'll have 25.14139, 25.139, and if 9 is removed then we'll have 1 in second digit after decimal point, 25.14 meter per second square. Therefore, acceleration due to gravity is 25.14 meter per second square. Now, numerical is not finished because another part of the question is left. Again, we can say that W equal to mg, because we know that weight of the body is the product of its mass and acceleration due to gravity, and taking the value of m 75 and g 25.14 meter per second square, we will get 1885.5 Newton, and this is the weight of the man on the surface of the Jupiter. This is our final answer. Okay, let's go to another part. Okay, let's come back to the same factors affecting the g. For the first case, we use this equation, g equal to capital G capital M by r square. Using this equation, we can calculate the value of small g at different parts of the surface of the earth. But for the height, I mean to say the second case, we have to use this equation. If we have to calculate the acceleration due to gravity at certain height, let's say at this place something is if falling, then at this place acceleration due to gravity is not equal to the acceleration due to gravity on the surface. It is less, and it can be calculated by using this equation. Instead of g, we can use g dash equal to capital G capital M remains same. The distance from center of the earth to the body is equal to not only radius of the earth, radius plus height from the surface of the earth. That's why the same equation converts to this type, and we can use this equation to find the acceleration due to gravity at height. Now let's go through some reason question. A body falls faster at pole than that of the equator. This is one of the famous question. If it is asked in the examination or any other places, first you have to understand this. This is earth, which is flattened at the pole, and polar radius is less, but this is equatorial radius is more, and due to less radius at pole, the value of g is more. It is about 9.83 meter per second square. Previously we declared that g is inversely proportional to the square of the radius of the earth, already proved. That's why if radius is less, g will be more. It is 9.83 meter per second square at North Pole. But if radius is more, g is less, and it is 9.78 meter per second square at equator. Okay, if a body is dropped at pole, then it falls with this acceleration, and if the same is dropped at equator, then it will fall with this acceleration. It means acceleration is more at pole, so the body falls faster at pole. We can write this way: earth is flattened at the pole but bulged at the equator, so polar radius is less than the equatorial radius. Since small g is inversely proportional to the square of the radius of the earth, so it is more at pole than the equator. Hence, a body falls faster at pole than the equator. Okay, there is another famous question. It is frequently asked in the examination. G varies from place to place of the earth. Why? We can understand this way. Let's say this is earth, and this is the radius of the earth at pole. This is at the equator, and this is somewhere at other place, and this is also at other place. It means radius keeps on increasing from pole to the equator, and it becomes maximum at equator. And when radius is less, g will be more, and that's why g will be maximum at pole, and radius is increasing from this pole to the equator, and if radius is increasing, the value of g goes on decreasing and becomes minimum at equator. So g varies from place to place of the earth, and the conclusion is g is more where at pole and it is less where at equator, and it varies from place to place of the earth. Okay, how can we write this? Earth is flattened at the pole but bulged at the equator. So polar radius is less but equatorial radius is more, and radius is different in different places of the earth since g is inversely proportional to the square of the radius of the earth, and due to the variation of radius g is different in different parts of the earth. Okay, let's move to another. G is less at depth of the earth. Why? This is very interesting. If a body is on the surface of the earth, then the whole mass of the earth attracts it towards its center. But if the same is taken inside, then the whole mass doesn't attract it towards its center. A part of the mass which lies below this body pulls it towards its center, but a part of the mass which is left behind pulls it away from the center. It means Earth's mass pulls it in different direction. That's why acceleration is because of the gravity of the earth, and the gravity alters because it is attracted towards different direction. That's why inside the earth the value of g will be less. It is less inside the earth and it is more on the surface of the earth. Now how can we write this? When a body is on the earth's surface, then whole mass of the earth attracts it towards its center. So gravity will be more on the body. When the body is taken to the depth, the mass left above the body pulls it in the opposite direction than that of the earth's center. So the resultant force of the gravity on the body will be less. Hence the acceleration due to gravity, that is g, will also be less. Okay, let's move to another question. Effect of rotation of the earth on g. Earth is rotating around its axis. Because of this rotation, the substances which are present on the surface of the earth are also rotating in a circular path. If a body moves in a circular path, then a force x in the opposite direction than that of its center, that is called centrifugal force. And this centrifugal force acts on each and every object lying on the surface of the earth, which tends to move the body away from the earth. On the other side, gravity pulls the body towards its center. It means centrifugal force is acting against the gravity of the earth. And because of this force, the gravity is reduced, and due to the reduction of gravity, the acceleration produced due to this gravity will also be less. It can be answered this way. Value of g is decreased due to the rotation of the earth. Earth is rotating around its axis, so every object lying on its surface is also rotating. If a body moves in a circular path, a centrifugal force acts in the opposite direction than that of the gravity force, so gravity of the earth will be less. Hence, acceleration due to gravity will also be less. Okay, I told you many things related to the acceleration due to gravity. There are four major factors on which it depends: radius, height, depth, and rotation of the earth. All these are answered. Now we'll meet in another class.